Electrophiles and classification of electrophiles. This is today's lesson. In this lesson, we are going to learn what are electrophiles and what is the reason behind being electrophile. So, let's begin. What is the definition of electrophile? Let's write the term electrophile and analyze the word. Electrophile. This word is analyzed as electron and phile. Electron, negatively charged particle, and phile means loving. That is, electrophile means electron loving. So the definition is the species that is electron loving is called electrophile. The species having tendency to receive electrons are called electrophiles. Now let's see classification of electrophiles. Electrophiles, electron loving species are called electrophiles. Electrophiles are classified as two groups. One is positively charged electrophiles and another one is neutral electrophile. Positively charged electrophile, all cations like carbonium ion, nitronium ion, bromonium ion, hydronium ion, proton, etc. All positively charged species are positively charged electrophiles. Here, this is nitronium ion. It is produced from the reaction between nitric acid and sulfuric acid. This ion is formed then by sulfate ion and water. So this ion is called nitronium ion, which is positively charged, acts as positively charged electrophile. Another one is bromonium ion. In many reactions, bromine molecule undergoes a heterolytic fission and then bromine plus and bromine minus. These two types of ions are formed. One is bromide ion, another one is bromine cation or bromonium ion. This bromonium ion acts as positively charged electrophile as well. Now let's see neutral electrophile. Here, neutral species having tendency to receive electrons are called neutral electrophiles. Though these species are neutral, but there is a shortage of electrons. That is why these species are electron loving. Let's see some examples of neutral electrophiles. Here, first one is aluminum chloride, which is neutral but acts as electrophile, neutral electrophile. Then beryllium chloride, ferric chloride, boron trifluoride, sulfur trioxide, carbon dioxide, zinc chloride, stannous chloride, stannic chloride, etc. These are neutral electrophiles. Neutral electrophiles are denoted by E and positively charged electrophiles are denoted by E+. Now let's see why this is electrophile, neutral electrophile. Let's see about aluminum chloride. Aluminum chloride is a kind of covalent compound. Then its formula will be this. That is, around aluminum there are 6 electrons, which is octet not fulfilled. So it has tendency to receive another pair of electrons. That is why aluminum chloride acts as neutral electrophile. Now let's see about beryllium chloride. Beryllium chloride, it's a kind of covalent compound. Then around beryllium there are 2 electrons. That is why beryllium chloride acts as neutral electrophile, which is not octet fulfilled. That is why it has tendency to receive more electrons. So it's a kind of neutral electrophile. Now let's see about ferric chloride. It's a kind of ionic compound. Let's see electronic configuration of ion 26, that is 3d6 4s2. To form this ionic compound, ion donates 3 electrons from these orbitals. So 3d5, then 4s0. From these 2 orbitals, ion donates 3 electrons. Now its configuration is 3d5 4s0. That means here ion minus minus minus, here 3 plus. It has vacant orbitals, d orbital, 4s, 4p, 4d orbitals. Those orbitals are vacant, so it has tendency to receive electron pair. That is why ferric chloride acts as neutral electrophile. Let's see about boron trifluoride. Boron trifluoride, it's a kind of covalent compound. Now let's draw the structure formula of boron trifluoride. This is boron trifluoride. Around boron there are 6 electrons, which is not octet fulfilled, so it has tendency to receive electrons. That is why neutral molecule boron trifluoride acts as neutral electrophile. Now let's see about sulfur trioxide. This is a structure formula of sulfur trioxide, in which oxygen's electronegativity is very high, 3.5, but sulfur is 2.5. That is why these oxygen atoms withdraw electrons towards itself, and as a result positive charge is developed over the sulfur atom. That is why sulfur trioxide acts as neutral electrophile, because of these positive charge developed for the highly electronegative oxygen atoms. Now let's see about carbon dioxide. Structure formula of carbon dioxide is this, which is a kind of covalent molecule. Here electronegativity of oxygen is higher than carbon. That is why covalently bonded electrons move towards oxygen and positive charge is developed over carbon. Because of this positive charge, carbon dioxide molecule acts as neutral electrophile. Now let's see about zinc chloride. This is zinc chloride, which is a kind of ionic compound. Then let's see electronic configuration of zinc. zinc 2 plus, that is 3D10 4S0. This is electronic configuration of zinc 2 plus, that is here zinc is present as zinc 2 plus. Now let's see zinc 2 plus, chlorine minus, chlorine minus. Around zinc 2 plus ion there are some orbitals like 4p, 4d which are vacant. So because of the presence of vacant orbitals in zinc, in the zinc chloride molecule, zinc chloride acts as neutral electrophile because it has tendency to receive electrons. Now let's see about stannous chloride. Stannous chloride, it's a kind of ionic compound. Now let's see electronic configuration of tin. Tin is 50. Electronic configuration is 4D10, 5S2 and 5P2. As this is ionic compound, so here tin 2 plus, chlorine minus, here chlorine minus. That is tin donated these 2 electrons. After donating these 2 electrons, now this zinc 2 plus ion has some vacant orbitals like 5p, 5d. Because of these vacant orbitals, stannous chloride acts as neutral electrophile because it has tendency to receive electrons in vacant orbitals. Now let's see about stannic chloride. Stannic chloride is a kind of covalent compound. Let's see structure formula of tin stannic chloride is this. That is here tin used these 4 electrons to form covalent bond. After forming covalent bonds, number 1, it has 5d orbitals which are vacant. Number 2, electronegativity of chlorine is 3.0, whereas electronegativity of tin is 1.8. That is why covalently bonded electrons move towards chlorine and positive charge is developed over tin. Because of this positive charge, stannic chloride acts as neutral electrophile. This is all about electrophile and classification of electrophiles. No more today. Thank you very much.